welcome to lecture number 31 of fuzzy sets, logic and systems and applications. In this lecture, we will cover projection of fuzzy relation set. So, let us consider a fuzzy relation first, represented by capital R, and this R is subset of or equal to Cartesian product of fuzzy set capital A and B. That means, R basically is either a subset of A cross B or R is equal to the Cartesian product of A and B, that means A cross B. So, we have already seen that how this R looks like. So, when we take the Cartesian product, A of course is defined in the universe of discourse in X, and B is defined in the universe of discourse Y. So, when we define R, when we define a fuzzy relation, you can see here, that is R. So, R can be expressed by A cross B. So, it means the Cartesian product of these two fuzzy sets A and B, and this is equal to the set of all the elements x, y along with associated membership values. And here the membership values that are there in the set associated with x, y, all these will again depend on x and y. So, this way we see that fuzzy relation. So, it is represented by capital R. So, R is a multi-dimensional fuzzy set. So, here in this case we have R A cross B, and A cross B, as I mentioned, is in terms of x and y, means we have the universe of discourse x and y. So, the Cartesian space that we have here is the capital X cross capital Y. Now, let us discuss the projection of fuzzy relation. What is a projection of fuzzy relation? As I already mentioned, that a fuzzy relation is a multi-dimensional fuzzy set. When we say multi-dimensional, it means that we have the relation fuzzy set is defined on multiple universe of discourse, like x and y, or even more, even further, like x, y, z and so on. So, when we have fuzzy relation R, if we are interested in projecting this R to its constituent sets, like here in this case we have A and B. So, if we are interested in projecting the relation set R on A, and we know that the universe of discourse of the fuzzy set A is X. So, before I move to the membership function of this, let me tell you that the projection of any fuzzy set reduces the dimensionality. What does this mean? This means that if we have any multidimensional set and if we project this fuzzy set to some other set, the projection is going to reduce the dimensionality of the original set, and it reduces the dimensionality when we project. So, let us now understand the projection. So, projection basically here when we talk of the fuzzy relation is defined in the universe of discourse x cross y. So, it means it is a multidimensional fuzzy set. When we are going to project this R either on A, which is a constituent fuzzy set, or on B fuzzy set, which is again a constituent fuzzy set. So, we can project this fuzzy relation set either on A or on B. So, when we say project fuzzy relation set R on fuzzy set A, it means we are reducing the dimensionality, and when we are reducing the dimensionality, it means that when we are projecting R on A, it means we are retaining its resulting fuzzy set. It means we are retaining the universe of discourse X, because we are projecting R on A. Similarly, when we are projecting the relation fuzzy set R on B, so this means that we are going to retain the universe of discourse Y of the resulting fuzzy set. Let this be represented by the projection of R on A is represented by R subscript capital A, and here similarly the projection of R on B is represented by capital R subscript B. So, as I mentioned that the resulting fuzzy set is going to be a fuzzy set with reduced dimensionality. It means that the universe of discourse is going to be reduced. So, in this case, since we are taking capital R, which is defined in the universe of discourse X and Y. So, if we are projecting the relation fuzzy set R on A, it means we are going to have only one universe of discourse of the resulting set, and that is again, since this is the projection is on A, the universe of discourse will be only A. So, this is here the expression by which we can reduce the dimensionality, we can get the projection of R, and the resulting fuzzy sets membership values can be computed by this expression. Similarly, when we talk of the projection of relation fuzzy set R on B, we use this expression for reducing the dimensionality. That means, the projection of R on B, that is R subscript B, and here the membership values can be computed by this expression, and that is why we are writing here as mu subscript capital R subscript B. So, when we have the membership values of the resulting set, when we get by this expression, and here in the other case when we are projecting R on B, we get by this expression. So, when the membership values are known, obviously it is easier to write the resulting fuzzy set. So, if let us say I am interested in writing the resulting fuzzy set in continuous domain. So, this is going to be like this. So, of course, this R A will be only the function of R, means we will have only the universe of discourse X here, and this is in continuous form. This will be like this, mu R A X, and then we have small x. So, this is the continuous form. So, the resulting fuzzy set R A X after projection we are going to get like this. Similarly, here we are going to get the capital R subscript capital B like this. Here also have the universe of discourse only Y. So, we can write Y here, and capital Y as the universe of discourse, and mu B Y and then Y. So, this is how we can represent the resulting fuzzy set. This is exactly the same here if we are interested in writing this mu R A of x. So, let us now better understand this by taking a very interesting example. So, let us assume that we have multi-dimensional relation fuzzy set. Here in our case we have fuzzy set represented by the surface. So, or in other words I would say we have let us say a continuous relation fuzzy set R, and which is defined in two universe of discourses like x and y. So, we have here the generic variable value x and y, and of course, then we have the universe of discourse as capital X cross capital Y. So, this is our R, the relation fuzzy set. Now, you see here this fuzzy set is a projection of R on fuzzy set A. So, you see as I already mentioned that this is represented by mu R A of x. So, this is nothing but the projection, and you see this is coming in only one dimension. Similarly, this will be our mu R B y. So, this means that the membership values can be represented by mu R B of y only, and here in this case when we have the projection of R on A, the membership values will be represented by mu R A of x. So, it is very interesting to note that projection here in this case is also reducing the dimension. So, earlier R was defined in the universe of discourse capital X cross capital Y. Now, when it is projected on A, the universe of discourse Y is eliminated. So, you see here when we project capital R, and this capital R, if it is projected on A, Y is eliminated, only X is retained. Similarly, if R is projected on B, only Y is retained, X is eliminated. So, this has to be noted, and this also can be understood by discrete fuzzy relation set example. So, we are taking here one example where we have two discrete fuzzy sets A and B, and here we will first form a relation fuzzy set, and then from the relation fuzzy set we will see how the projection of fuzzy relation R on A and projection of fuzzy relation R on B. So, let us now go ahead and try this example. So, as I mentioned that we have two discrete fuzzy sets, we already have done this thing, that as to how we can quickly get from these two fuzzy sets A and B, how we can get a fuzzy relation set. So, our relation set is here, you can see. So, we will just have to get the Cartesian product of these two A and B fuzzy sets, and here we write our relation fuzzy set R, which is again this relation fuzzy set is basically is defined in the universe of discourse X and Y. So, this can also be written as R of X Y. Remember, this R is a multi-dimensional fuzzy set. So, if we look at A fuzzy set, we see that it is a one dimensional fuzzy set, although it is represented in two dimensional space, because we have the generic variable values x 1, x 2, x 3 and so on, and then we have the corresponding membership values like mu of x 1, mu of x 2, mu of x 3 and so on. So, we represent this in two dimensional space, but it is a single dimensional fuzzy set. Similarly, the B also, and here our relation fuzzy set, that is R x y, becomes this way the three dimensional fuzzy set. Actually, it is a two dimensional fuzzy set because only x and y are the generic variable values, but the representation of this fuzzy set is in three dimensional, because one more dimension which is needed here is, apart from x and y, we need mu of x comma y for the associated membership values. So, as we see here that we have the R of x comma y as the fuzzy relation set R here. Now, this can be represented in the form of fuzzy relation matrix. The same we know as to how we can manage to convert this into the matrix form. You see here the R, we have the column and then we have rows. So, column is basically x 1, x 2, x 3 and rows are x y 1, y 2, y 3 and then here these are the min values. So, we know as to how we can get the relation matrix. We have already done this, so I am not going to discuss this again. We now represent this whole thing, this relation fuzzy set into the matrix form. So, we call this as the fuzzy relation matrix. So, now when we have the fuzzy relation matrix R, let us now find out the projection of fuzzy relation R on A, as we have already discussed. So, when we say projection of fuzzy relation R on A, it means that we have to retain only x generic variable and we have to eliminate y generic variable value, and when we apply the expression for doing this, this means that the R which is going to be the resulting fuzzy set will look like this. So, we call, when we say the projection of fuzzy relation R on A, we represent this by R A, and also this R A now will retain only the x as the generic variable, and this R A will be basically if we represent this in discrete form, this will be like this. So, mu R A x and then x. So, this will, the whole fuzzy set will look like this, and now how to get this mu R A x. So, this mu R A x can be, we can get from here. So, when we use this expression, the expression is mu R A of x is equal to max over all y's mu R of x comma y. So, we see that we have a fuzzy relation matrix R. So, when we apply this, we see that for the first row corresponding to x 1, we see that we have to take the maximum of all the elements in the first row. So, similarly, when we take maximum all the values, all the elements in x 2 row and x 3 row, we find this matrix which is the column matrix. So, this is called R A and this is equal to the column matrix 0.2, 0.4, 0.5, and this can be written as in the normal form is the summation form. So, when we write the summation form, we can write it like this, like R A is nothing but this R A is equal to 0.2 by x 1 plus 0.4 by x 2 plus 0.5 by x 3. So, this is how we get the projection of fuzzy relation set on A, and this is represented by the capital R subscript A of x. Now, similarly, when it comes to projecting the same fuzzy relation capital R on the same lines, we move ahead. So, we have here the relation fuzzy set, which is again the defined on two generic variables. So, as I have discussed for the projection of fuzzy relation R on B on the same lines, when we apply this expression, this criteria on the relation fuzzy set, we get a row matrix. Here, since we are projecting the relation fuzzy set on B, we are eliminating x, we are retaining only y. So, that is why we see that we are taking the max for all the column values, max of all the column values means over all x values. So, that is why all the 3 rows are reduced to only single row. So, we see that we get these 3 elements only, and this is nothing but R B, and which is defined on only y. and this can be represented by the normal fuzzy representation form, and which is actually 0.5 oblique y 1 plus 0.1 oblique y 2 plus 0.5 oblique y 3. So, this way we have got the projection of fuzzy relation R on A and on B, and in both the cases we have seen that the original fuzzy relation set R was the multidimensional, that means both the R was on x and y, but here when we have projected this either A or B, we saw that we have reduced the dimension by 1. So, this way we can generalize the projection of fuzzy relation R. So, R in n dimension. So, let us understand this here better. So, the projection of a fuzzy relation let us say R can be extended to n dimension. So, let relation R is defined among fuzzy sets A 1, A 2, A 3, A 4 and so on up to A small n, where small n is the total number of generic variables. So, accordingly we will have a space here. So, the universe of discourse space will be capital X 1 cross capital X 2 cross capital X 3 and so on cross capital X n. So, we can project this relation to X 1 cross X 2 cross X 3 and so on cross X k. So, we are taking some multiple dimensions where let us say up to k is the dimension where we are projecting. So, when we project the n dimensional fuzzy relation set into k dimensional space. So, what we are getting is here. So, we represent this the resulting relation fuzzy set by capital R A 1 cross A 2 cross and so on cross A k. It means here we are retaining only this universe of discourse, means k universe of discourse. So, the membership values of this projected relation can also be computed, and this is computed by this relation here. So, this is self explanatory. So, we define the membership value of the resulting fuzzy set, and this resulting fuzzy set of course will have k universe of discourse. I should not say k universe of discourse, but I will say the universe of discourse will be the Cartesian product of k generic variable. So, here mu r A 1 cross A 2 cross and so on cross A k of x 1 comma x 2 dot dot comma x k will be equal to max over x 1, x 2 and so on up to x m, and then this is mu r of x 1 comma x 2 and so on x n. And then of course, this x 1, x 2 up to x n, all these will belong to the Cartesian product of, or I would say the universe of discourse x 1 cross x 2 cross x 3 cross x 4 and so on cross x n. So, this way it is defined, and here this k plus m. So, here it is to be noted that the total number of dimensions are the generic variables that are there, the total number is here n. So, we have small n total number of generic variables, the relation fuzzy set, and this relation fuzzy set is projected in the k universe of discourse or k generic variable based fuzzy set. So, what is the elimination here is the m. the m generic variable values are eliminated. So, what does this mean? It means that the k plus m is going to be equal to m, means the total generic variables that we had initially is n, and then the resulting fuzzy set after projection we have small k, and then the small m here is the generic variable values that are eliminated by this projection. So, this way we have understood as to how this projection of fuzzy relation in n dimension is done. And this is also to be noted here that the relation that I have just mentioned among the universe of discourse or the generic variable values here. So, this can be understood by the union. So, here the total universe of discourse are, I would say, the generic variable values is equal to the union of the k generic variables and then the m generic variables. So, this way we have understood as to how we can project fuzzy relation in the reduced dimension. So, as I have already mentioned that the projection of fuzzy relation always gives a resulting fuzzy set which will have the dimension less than the dimension of the fuzzy relation set. So, this way we have understood the projection of fuzzy relation very clearly, and the remaining part, that is the cylindrical extension of fuzzy set, will be covered in the next lecture. Thank you.